Imagine the entire planet locked in a deep freeze. Oceans sealed beneath thick ice, snow stretching from pole to pole, and global temperatures plummeting to life-threatening lows. It may sound like science fiction, but around 700 million years ago, Earth really did become a giant snowball. This extraordinary period, known as Snowball Earth, is one of the most dramatic climate events in our planet's history, and scientists are still uncovering the clues to how it happened. The Snowball Earth hypothesis suggests that during a time known as the Cryogenian Period, roughly 720 to 635 million years ago, the entire planet became almost completely frozen. Ice sheets advanced from the poles all the way to the equator. Two major glaciations took place: the Sturtian glaciation, starting around 717 million years ago and lasting nearly 57 million years, and the Minoan glaciation, which ended about 632 million years ago. These ice ages plunged global temperatures possibly as low as -50 degrees Celsius. With the sun's energy weaker than it is today, and so much sunlight being reflected by the expanding ice, Earth remained locked in this frozen state for millions of years. But what could have triggered such a massive freeze? Scientists believe the key lies in a sudden collapse of greenhouse gases like carbon dioxide. Around this time, tectonic activity reduced volcanic emissions from mid-ocean ridges, which had previously helped maintain atmospheric CO levels. Meanwhile, newly formed mountain ranges, particularly those in ancient Canada, were being rapidly weathered by rainfall. This chemical weathering pulled vast amounts of CO out of the air. With so little greenhouse gas to trap heat, Earth's temperature dropped sharply. Once glaciers reached around 25 to 30 degrees latitude, the ice albedo feedback loop kicked in. The more ice formed, the more sunlight was reflected away, causing even more ice to form. To make matters worse, some scientists think volcanic eruptions or biological blooms may have released aerosols or clouds that dimmed sunlight even further, pushing the planet past a critical tipping point. We know this global freeze happened thanks to evidence found in rocks all over the world. Geologists have discovered ancient glacial deposits, like dropstones and till, in areas that were once near the equator. These features are signs that glaciers existed even in tropical zones, something that could only happen if the planet was truly covered in ice. Such deposits have been identified in places like South Australia, Namibia, and China. Climate models also show that if ice ever advanced close enough to the equator, Earth's reflective surface would create a feedback loop, making a full freeze almost inevitable. Now, you might be wondering, how did anything survive? After all, this happened hundreds of millions of years before dinosaurs or plants ever existed. Life at the time consisted mostly of microbes and simple single-celled organisms. Scientists think some of these organisms survived in meltwater ponds on top of the equatorial ice, where the ice was thinner and could absorb enough sunlight to create small liquid refuges. Modern studies of Antarctica show that similar melt ponds today can harbor thriving microbial communities, including algae-like cells, amoebas, and other extremophiles. Other life may have hung on near hydrothermal vents deep in the oceans, or in small cracks where water remained unfrozen. Eventually, the freeze came to an end. While Earth's surface remained frozen, volcanoes beneath the ice continued to erupt, slowly pumping carbon dioxide into the atmosphere. Because chemical weathering had stopped, nothing removed this CO, so it kept building up. Over millions of years, these greenhouse gases reached concentrations high enough to trigger a global meltdown. The ice sheets began to retreat, and massive floods rushed across the continents and into the oceans, carrying nutrients that likely changed the chemistry of the seas forever. Some scientists believe this dramatic thaw may have helped spark the rise of multicellular life by delivering the nutrients that early organisms needed to evolve. The Snowball Earth period is a powerful reminder of how fragile and dynamic our planet's climate can be. From a world frozen solid to a thriving cradle of complex life, Earth has undergone transformations beyond imagination. And we're still learning how life found a way, even during the coldest chapter in our planet's history. So, what do you think? Could life survive if Earth ever froze over again? Let us know in the comments, and if you enjoyed this deep dive into Earth's frozen past, be sure to like, subscribe, and hit the bell for more fascinating science stories. Until next time, stay curious.